Welcome. Today, we're going to learn to graph linear inequalities. This is T3, by the way, in Algebra 1. A linear inequality is a line where we're either going to shade above or below, or maybe it's to the right or to the left, depending on how you look at it. But to do this, the first thing I like to do is treat the inequality like it's an equation. I'm going to treat it like it's just x equals -4. So I'm going to treat that inequality symbol as an equal sign. Now I'm going to graph this. Now, this is either a vertical or a horizontal line. And do you remember which it is? When there's only one variable shown, it's either the horizontal or the vertical. What I do is I go, since it shows an x, I go along the x-axis till I get to a -4, and I click on that, and I'm going to keep x -4. That means I have to go up or down. If I move to the right or left, x isn't -4 anymore. So now I have a vertical line, or I've graphed the line x equals -4. But now I want to go back to the inequality. I'm going to go back to the x is greater than -4. So I really want to graph this, which without an equal sign underneath the inequality symbol, I'm not going to include all the points along the actual line. To indicate that I'm not including the points, I click on it again and get this dashed line. The dashed line just means, hey, I'm not going to use the points on the line. I'm just going to go up to the line. Now the question is, do I shade on the right side of the line or on the left side of the line? The way I find that out is I pick a point. Usually I pick the easiest point, which if it's not on the line, I pick the point 0, 0. So I come over here and I pick the point 0, 0. Now remember, that's an x and a y value. I'm going to replace the variables. Now there's only one variable, x. So I'm going to replace x with a 0. And I'm going to ask myself, does it make the inequality true? Is 0 greater than -4? Well, 0 is greater than. It's to the right of -4. So that point works. I'm going to click, and it actually highlights that whole side. And that's telling me that every point on that side of the line is a solution to this inequality. Hit submit. Lo and behold, excellent. We did it right. So now here, it's going to do another line. Again, another linear inequality. First thing I'm going to do is treat it like it's an equation. Y equals 7. Now again, since there's only one variable, that's either a horizontal or vertical line. Do you remember which it is? Well, since the y is the variable I see, I'm going to go on the y-axis till I get to a value of 7, and I want to keep y7. That means I can't go up and down. I can just go left and right, and it doesn't matter where left or right I click. I just click this horizontal line. Now I'm going to think of that actual inequality. The inequality was y was greater than or equal to 7. Now I do have an equal sign. That equal sign underneath the inequality means I do include every point on the line. So I'm going to leave it solid. Don't make it dashed. Now to know whether to shade below or above it, again, I'm going to pick the easiest point. I'm going to pick the point 0, 0, where x is 0 and y is 0. Now, the equation only has a y value, or a y, so I'm not going to worry about the x being 0. I'm just going to plug in a 0 for y and ask, is 0 greater than or equal to 7? 0 is not. That's false. What that means is this point here, the origin, is not a solution. I need to be on the other side of the line, which means above it. So I'm just going to come up here somewhere and click. I'm going to shade everywhere above it because the point below it didn't work. Now it's moving on to a linear equation or linear inequality that has an actual slope. But again, I treat it as y equals -5x. Again, there's no b value at the end, so that means my b value or my y-intercept is 0. My slope is -5/1, so I'm going to go down 5 and right 1. I'm going to click to form my line. Now I'm going to go back to the actual inequality, and I'm just going to write it in right here. It was a strict less than. There's no equal sign underneath it. If you look over here, no equal sign. That means this line needs to be dashed, so I'm not including the points on the line. Now I need to decide, am I to the left of it or to the right of it? Now, I can't use the point 0, 0 because the origin's on the line. You have to use a point that's off the line. So I usually use one of the easiest points I can use, either 1, 1 or 2, 2. Maybe I use 2, 0 or 1, 0, but I'm going to use the point 1, 1. So I'm going to use the point 1, 1. So x is 1 and y is 1, and I'm going to plug that into my actual inequality. So I'm going to plug a 1 in for y, and I'm going to go -5 times 1, because x is also 1. and then I get, is 1 less than -5? 1 is not less than -5. 1 is greater than any positive or any negative value. So that's false. Again, since it's a false statement, since that point didn't work, I'm on the wrong side of this line. I need to be over here. So I'm going to click over there, and I get it right. Right? So I'm going to jump ahead now. So we get even some harder ones. Like, for instance, here's, again, an equation that's in slope-intercept form, which makes it, I think, fairly simple. Because, again, the first thing I do is I graph it as y equals 4x minus 3. That tells me my y-intercept is 3. My slope is 4. So I'm going to come down here to -3. Click on my -3. My slope is 4, so I'm going to go up 1, 2, 3, 4, and write 1, because remember I treat all integers as a fraction over 1 to find my slope. Now I'm going to think of it as the inequality. It's a less than or equal to. Since there's an equal symbol underneath it, I'm going to leave the line solid. And I like that the origin, this point right here, is not part of the line. So I'm going to plug in the point 0, 0 to see if those values of x and y make the inequality true or false. If it makes it true, then I know that's the right side of the equation or line to be on. If it makes it false, I need to be on the other side. So here we go. I'm going to plug a 0 in for y, and I'm going to see if that is less than or equal to 4 times 0, because I'm plugging a 0 in for x, minus 3. So is 0 less than or equal to, well, 4 times 0 is 0. 0 minus 3 is -3. Is 0 less than or equal to -3? It is not. That is false. So I want to be on the other side. That origin point right here didn't work. So I click over here. And all of them are going to be very similar to this. Eventually, though, they're going to get to some equations that are not written in slope-intercept form. So the way I do these is I find my x and y intercepts to graph it first, and then I look at the inequality. So for what I mean by that is I'm just going to treat it as a 3x plus y equals -2, and I'm going to find my x and y intercepts. Well, actually, that might not work because my x-intercept's going to be a negative, or going to be a fraction. So I might actually solve for y. So what I'm going to do is I'm going to take the -3x and minus it over here. So I get y equals -3x minus 2, because those two terms are not like terms. Now I know my slope, and now I know my y-intercept. So I'm going to go to -2. I'm going to have a slope of -3, so I'm going to go down 3 and right 1. Now I'm going to go back to the original inequality. Don't use this equation here because it's an equation, not an inequality. And you're more likely to get it right if you use the original than if you try to use the altered version. So we come back up here, and I first go, well, there is no equal sign underneath it. So my line should be dashed because I'm not including points actually on the line. But now I need to know if I'm on the right side or the left side. Which side am I on? Now again, if I notice that origin point right here is not part of the line, so I'm going to plug in the point 0, 0 into my original inequality. So I'm going to plug in a 0 for the x plus 0 for the y and see if that's greater than -2. Well, 3 times 0 is 0. 0 plus 0 is 0. And the question is 0 greater than -2? 0 is greater than -2. So when I plugged in the 0, 0, I got a true inequality. So I know that this point's correct. So I want to be on this side of the line. And I click. Again, this one here, this is the one that I think would be so much easier just to find the x and y intercepts, right? X plus y equals 1. Make x 0, that tells me y is 1. Make y 0, that tells me x is 1. So I know I have an x and y intercept of 1 and 1. Then I look back at the inequality. I notice that the inequality has an equal sign underneath it. That means I want a solid line. I'm going to plug in the point 0, 0 to see if it makes it true. So 0 plus 0, is that greater than or equal to 1? 0 is not greater than or equal to 1. So it's a false statement. So that means that origin point, the 0, 0, does not work. I want to be on the other side of the line. Hopefully this makes sense. I'm going to jump ahead just to make sure that I see anything that might be harder, but they all look fairly much the same as this. Again, back to linear or slope-intercept form. Slope-intercept form. So just to show you how quick you should be able to do this, y-intercept of 4, slope of 2/3, up 2, right 3. I do not see an equal sign, so I click on the line to make it dashed, and now I'm going to plug in this 0, 0 point. So is 0 less than 4? Because what's 0 times the slope? That's 0. Is 0 less than 4? Yes, 0 is less than 4. So 0, 0 worked. So I click that side of the line, hit submit, and I did great. Now let's look at this. This is no different. Let's go to the next. Yeah, okay, so let's do this one. This one here. This one might be a little bit harder because, again, the x-intercept is not integer. So again, just to show you how quickly, though, you should be able to do this. Again, I'm writing it first as an equation. I'm going to minus 7x from both sides. That leaves me a negative 5y is equal to negative 7x minus 10. Now I'm going to divide by the negative 5, divide by the negative 5. I get y is equal to a negative 7 divided by a negative 5 is going to be a positive 7/5 x. Negative 10 divided by negative 5 will be a plus 2. I can see my y-intercept. I can see my slope. So my y-intercept was 2. My slope was a positive 7/5. So I go up 7 over 5. Now, don't use this expression here. Go back to the original expression, and I'm going to put in that inequality symbol the way it was. So now that I have that inequality the way it is, I'm going to notice that there is an equal sign. So I'm going to leave the line solid, and now I'm going to try this origin point of 0, 0. So I'm going to go 7 times 0, because I'm making x 0. 7 times 0 is 0. Plug in a 0 for the y. 5 times 0 is 0. That's what I like. It's very quick and easy. 0 minus 0 is 0. Is 0 greater than or equal to negative 10? Whoops, you can't quite see that. Negative 10, because that's what the problem says. Is 0 minus 0 greater than or equal to negative 10? It is. This point here works. So I click it, and it shades the right side, and I get it correct. If you have any questions at all, please do bring them to class, and I will help you some more.